was asked to go over some stuff from last week, and that was involving, we had a calculation last week where we ended up with coulombs over amps, which then went to coulombs over, well, amps or coulombs per second, and just some confusion over how the units work in there. Um, First thing I want you to know is if you don't get how the units work in that calculation, you can just go straight from here, coulombs over amps, and you can end up over here. Okay, and the reason for that is that this math is maybe a little bit above your pay grade, right? You guys are only grade 9. So if you're absolutely not getting this and it's just confusing you, don't worry about it. Just be like, okay, I put my coulombs over my amps, and I know that I'm supposed to be finding time, which is in seconds, and you could just skip all of this stuff in between if you want to. However, I'm going to go through it a couple of different ways so that if you're interested in feeling more comfortable with this, this is certainly something that will help you with your senior sciences later on. Okay, so we had T is equal to Q, so time is equal to the charge divided by the current, I, and we had 18 coulombs over 24 amps. Now I'm just going to get rid of all the numbers altogether, and we're just going to work with the units to start with. So we have coulombs over amps. Okay, that's our unit. Coulombs over amps. And remember, amps is a measure of current, and current is how much charge, which is measured in coulombs, passes a point in a given time. And remember, time is in seconds. Okay, so current is the amount of charge, coulombs in a given amount of time, seconds. So an amp is a coulomb per second. So we could say that this is a coulomb. We have our coulombs here over amps, which is coulombs per second. Now what we have here is we have a complex fraction. Okay, so I want you to go through this with me. If I had a complex fraction that looked like this, 1 over a half, okay? 1 over anything is equal to the reciprocal of anything. Okay? 1/2, for example, is the reciprocal of 2. 2/7 is the reciprocal of 7/2. Okay? So all I'm doing is I'm flipping it upside down. Okay? So I'm flipping the whole thing upside down when I have the reciprocal of something. So when you divide by something, right, this is divide by, dividing by a fraction is the same as dividing by anything is the same as multiplying by its reciprocal. Okay, this is a huge key point here. Dividing by anything is the same as multiplying by the reciprocal. So if I am dividing by a half, okay, so I have 1 divided by a half, that's going to be the same as 1 multiplied by the reciprocal of 1/2. And the reciprocal of 1/2 is, well, actually I should have written 2 over 1. 2 over 1. So anytime you have a number and you want its reciprocal, you just flip it upside down. Okay, so the reciprocal of 1/2 is 2 over 1, which is just equal to 2. So 1 over 1/2 is equal to 1 times 2. You want to prove that to yourself? You want to prove that works? You can say I have 1 over 0.5. Yeah? How many times does 0.5 go into 1? 0.5 goes into 1 twice. Yes? So 1 over 1/2 is equal to 1 times 2, which is 2. Okay, and now we're going to take this back into the context of units, because remember we had coulombs over coulombs per second. And remember, dividing by something is the same as multiplying by its reciprocal. Okay, so I am dividing by coulombs per second. So coulombs divided by coulombs per second. That would be the same as taking coulombs and multiplying by, now we're going to multiply by the reciprocal of coulombs per second, and the reciprocal of coulombs per second is seconds per coulomb. Okay, and now we have a coulomb on the top and we have a coulomb on the bottom. Now when I say on the top, sometimes people get confused because they're like, is it on the top? Well, if you had anything on the bottom, it would just be a 1. So coulombs over 1 would just be coulombs, right? So this expression here and this expression here are the same. Okay, that one is just sort of there to say, yes, there's something on the bottom. You don't have to do that. You can just assume, as long as you write things properly, so that everything that's on the top is in the same line and everything that's in the bottom is in the same line. Okay, you see you've got your line here, you got your line here. As long as everything lines up okay, you don't actually have to write that 1 on the bottom. Okay, and then anytime you have something on the top and on the bottom, it can cancel out and you're left with seconds. Okay, so let's try that once more in context. So I have time is equal to the charge over the current, which is equal to, let's do some new values here just for fun. Let's say that we have 20 amps, and let's say our current, or amps is not the unit of charge, coulombs. I have 20 coulombs, and my current is, let's see, what's my current? My current, let's say it's 4 amps. Okay, you can actually do the math on the numbers first. Do the math on the numbers. That might make your life just a little bit easier. Okay, so now we have 20 divided by 4 is 5. Now my unit is coulombs over, remember an amp is a coulomb per second. And remember, when we divide by something, if you're dividing by something, that's the same as multiplying by its reciprocal. And what is the reciprocal? The reciprocal is just the same number upside down. Okay, so we're going to take, or the same concept upside down. So we're going to have coulombs, and we're going to multiply by the reciprocal of coulombs per second. We're going to flip that upside down, and that's going to be seconds per coulomb. Now I have coulombs on the top and coulombs on the bottom, and those cancel. I forgot my number. Oops, 5. And so we end up with 5 seconds as our final answer there. Okay, our second example here, we're going to be using the voltage equation. Remember, voltage is equal to the amount of energy, that's potential energy because it is stored, okay, in a given amount of charge, Q. So voltage, V, is equal to E for energy over Q for quantity of charge. And we are going to have a question where let's just say that the quantity, we want to find the quantity of charge, okay? And quantity of charge is measured in coulombs. And we are given that the energy is 18, no, let's not do 18. Let's do 24, like 24, it divides by a lot of stuff evenly. Okay, the energy is 24. What is the unit of energy? The unit of energy is the joule, okay? And our voltage, let's say that our voltage is 6 volts because there's, lots of 6-volt batteries and stuff like that. Okay, or you can make a 6-volt battery out of a bunch of 1.5 cells. All right, so let's say now that we want to solve this. Well, the first thing we need to do, remember our 6-step method, we have written out our given quantities and we've written out the quantity we want to find. We are going to write our formula, V equals E over Q, and we are going to solve for Q. I'm going to do the bring it up, bring it down method, so I'm going to bring up the Q because it was on the bottom. I bring it up to the top on the other side. So now I have Q is equal to E, and I've got my V here. And so I'm going to bring the V on down to the other side, and I'm going to end up with Q is equal to E over V. I would normally do that in one step. I'd just be like, I bring my Q up and then I bring my V down and I end up with Q is equal to E over V, but there we are. So this is what we're going to be working with. So now we have Q is equal to E over V, and we know that our energy is 24 joules. So now we're doing the plug and chug. So we're going to plug 24 joules over our voltage is 6 volts, 6 volts. Okay, and I'm going to take 24 divided by 6, and when I do that, I get the number 4. Now I have joules over, now remember a volt is the amount of energy, which is measured in joules, per quantity of charge. The amount of energy contained or stored in a quantity of charge, and the unit for quantity of charge is the coulomb. So a volt is a joule per coulomb. So volts, I can substitute, instead of volts, I can substitute joules per coulomb. Okay, so now we have joules over joules per coulomb. And remember, I am dividing by something. Divide is the same as multiply by reciprocal, right? So now what I'm going to do is I'm going to say I have 4 is equal to joules. Oh, 4 is equal to joules. Bah! 4 joules times, I want to take the reciprocal here, so I'm going to take coulombs over joules is the reciprocals of joules over coulombs. I now have a joule on the top and I have a joule on the bottom, so I end up with 4 coulombs. And that's it.